This is lesson 5.1. It's called Interpret Slope. And interpret means to understand, to figure out. So we're looking at slope and what it means, basically. So 5.1 is on page 150 if you have the textbook. That is the page that I'm working from. If you don't have the textbook, it's okay. I will put the things that you need to know in this writing. Those of you who do have the textbook, you can follow along with me if you want to. I'm not going to be reading everything in the textbook because there's a lot of interesting stuff there, but you don't want to sit and listen to me read. I promise you don't. So let's take a look at the concepts on page 150. The first thing that we need to really understand is the coordinate plane. And to do this one, I'm going to rotate this image, and I'm also going to enlarge it a little bit so you can really see. So if you have graph paper, this will help tremendously. I would recommend, if your children have some graph paper lying around, grab a few sheets just to have handy here. So we're going to draw a coordinate plane. So I want to start this by taking a straight edge. It's very important that this be straight. And drawing a horizontal line. I'm going to make that just a little bit bigger. So draw yourself a horizontal line in the middle of your graph. This is called the x-axis. It is horizontal. It runs left to right, and it runs to infinity. It can run as far as you want to let it run. It runs to infinity. This is positive infinity, which means it's endless. And this is negative infinity, which means it's endless in that direction. Some examples of this type of concept would be yards on a football field, moving one way or the other on a football field. It could be anything that involves moving from left to right, running back and forth, driving so many blocks on one street, and then turning and going back the way you came east-west. Okay, the other axis is the y-axis, and it is going to come through about right here on my graph. It's the vertical axis. I remembered it in school because the y is tall. It is like the vertical axis. And it runs from positive infinity, and infinity just means endlessness. It's symbolized by that sideways 8, figure 8, to negative infinity. Some examples of this type of graph would be a thermometer, temperature moving up and down on a thermometer. There is a very important point that you need to know about, and that is right here in the crosshair. If you shoot guns for sport, you will know that you're aiming at a crosshair sometimes, or you're sighting with a crosshair. This is called the origin. And the origin is at point 0, 0. You don't move left or right. You don't move up or down. You're just right there on 0, 0. In this ordered pair, you always have the x coordinate first. X before y is called an ordered pair. It's also called a coordinate. A coordinate requires an x and a y. It has to have both to be a coordinate. This is how global positioning systems work, GPS. The whole Earth is mapped in latitude and longitude. X-axis would be lines of latitude in a social studies book. Y-axis would be lines of longitude. Our time zones in the world are based on lines of longitude. So this has very practical applications in real life. This is one of the things in math that really you do use on a daily basis. You just may not realize that you're using it. Okay, you need to know about the quadrants, so let me show you those. This is called quadrants. Quad means 4. So 4 sections on this graph. This is quadrant 1, and this is labeled with Roman numerals. In quadrant 1, all dimensions are positive. Positive x's, positive y's. Quadrant 1 is all of this. I learned years ago that my students don't always catch that from the way I'm describing it. And it's me, it's not the student. I'm not describing it well. Quadrant 1 is all of this area to infinity. Okay. Then we move counterclockwise. I'm just going to go ahead and color quadrant 2 while I'm over here. And I already told you the name. This is quadrant 2. Can you figure out if the x's are positive and negative, and if the y's are positive and negative? And it may help you to remember what origin means. Origin is 0. Okay, so my y's are above 0, but my x's are back here, below 0. So in quadrant 2, you just use the black here. Quadrant 2, the x's are negative. They're behind the origin, and the y's are above its origin, so they are positive. So if you wrote that as an ordered pair, you would have a negative x value and a positive y value. Over here in quadrant 1, you have a positive x and a positive y. So can you picture the color, or not the color, but the quadrant I'm going to color next? Hopefully you can. We're moving on down. Remember, I'm moving counterclockwise. While I color, see if you can figure out if the x's are negative or positive, and if the y's are negative or positive. Consider origin. This is quadrant 3. And hopefully you realize that the x's, just like in that orange section, are in the negative range. They're to the left of origin. And the y's are below 0. They're also in the negative range. So this is going to be negative x, negative y. And I'm deliberately going slowly here because I want to let you process what I'm saying. We don't need to be in a rush to try to understand this. If you don't need this information, that's okay. Just go ahead and skip this video. That's fine. But if you're just learning this, this is important to really process what's going on. Finally, we have quadrant 4. And I've had students before, when I get here, I'll say, does anyone have a question while I'm coloring? And you know, one of the biggest questions I'm asked is, how do I write a 4 in a Roman numeral? It's a very good question. It is quadrant. In Roman numerals, you make the 5, which is the V, and you take 1 away from it. So you have quadrant 4. And in quadrant 4, the X's are to the right of origin, so they're positive. And the Y's are to the bottom of origin, so they're negative. So your X coordinate is positive, your Y coordinate is negative. And that, my friends, is called the coordinate plane. In geometry, a plane is a flat two-dimensional surface. And it's Plane. Okay, I'm going to stop this video. Actually, I'm not. Let's go ahead and do some plotting. This goes along with what I'm doing here. And I wonder... No, I'm going to stop this video because you don't need to sit and watch me do this. I'll be back in the next one and we'll plot some points.